Hi, I'm Rich with insideHPC, and we're here at the insideHPC booth. We're here to meet actually with SGI, Paul Kinyon. You know, Paul, let's start at the beginning. Who is SGI and who do you help?
Excellent, you bet. SGI is certainly a premier industry-leading technical leader in the HPC market. We ship systems, as you would say, from soup to nuts, literally from single standalone pizza boxes up through highly integrated bladed clusters in both a distributed memory and a shared memory environment. So we're definitely very well known in the industry for our shared memory endeavors, but we've really been a strong up-and-comer in the distributed memory market in a bladed environment. We help our customers solve the most challenging problems in the world, and what we do for them actually is take away all the problems of getting the systems on site, getting them installed, getting them up and ready, having the latest tools and technology at their fingertips the day it lands so that they can focus on doing their own work, finding answers to their problems, not to the system's problems. That's SGI in a quick nutshell.
You know, so Paul, you know, like this year at SC12, power and Exascale, these are big topics here. Can you help us relate those to each other? I mean, you know,
sure.
You know, let's connect the dots here.
Sure. Firstly, what I'd like to say is that power efficiency, you know, as it relates to the Exascale problem, is just one facet. Getting to Exascale is much more than just being able to power the systems. Though in response to your question, we'll go through what we're doing in that regard. So, if you look back through the history of supercomputing, it was roughly 1997 that the sum of all systems on the top 500 was a teraflop. About 4 years later, the first teraflop system appeared. So it'd be like 1997 time frame. It was about 11 years after that that the first petaflop system came onto that list. So 1,000 times improvement within about 11 years. If that trend holds, then that would mean we'd be hitting Exascale in roughly 2019. Will we get there exactly by then? I don't know. There's a lot of tough nuts to crack. For instance, the power, as you brought up, power efficiency. If we look at a sustained petaflop today, it's about 10 megawatts to do that. Now this is rough math, but just for ease of conversation. It can be done with more or less depending upon the style of sockets used, etc. But for rough math, let's call it $1 million a megawatt, and it's 10 megawatts roughly for a sustained petaflop. Times 1,000 to get to Exascale if we just did the same thing.
For a yearly power bill.
For a yearly power bill means it's $10 billion. That's
so no one has that operational budget.
No one
right?
has
so
that operational budget.
That's a non-starter, right?
So we have to start nibbling away at this problem, and we're doing, along with our strong partner Altair, taking several steps to start nibbling away and chewing and removing that cost and improving the power efficiency is certainly one way we're doing that.
Okay, so let's double click on that. You know, can you give some detail what SGI is doing in these areas?
You bet, Rich. SGI has a long and successful history in improving the power efficiency and the power management of systems. And I'd like to give some examples of how we do that, for instance, on the hardware side, and then I'll move and give you a starting feel for what we're doing on the software side with our partnership with Altair. So for instance, on the hardware side, for our high-end bladed cluster system, we've up-leveled the power and cooling of the systems to a much larger unit. If you think of little rack stack pizza boxes, right? Each one of those for HPC will have redundant power supplies and 4, even 8, 12 fans, little fans in it. So what we've done instead is we've taken that infrastructure and we've combined it and condensed it and commonized it at a much, much higher scale. So for instance, in this picture, what I'm showing is we have 2 racks full of gear, so like 288 nodes in this area being powered commonly and with 3 blowers. So with size and scale, you gain efficiencies. So this is on the hardware side. Now this is an interesting design and for a few different reasons besides just efficiency. It's closed loop. I should say besides the obvious efficiency of commonizing the power supplies, commonizing the fans. For the power supply, for instance, instead of having, if we have 288 nodes, we'd have 576 power supplies if we did this rack stack. Well, no, we're down in the tens of power supplies because we remove all those excess redundant power supplies. So that gives us efficiency, right, in terms of hardware. But not only that, this whole system is sealed like a box, right? So no airflow mixes with the data center at all. It's self-contained. That means we can run the temperature higher. So if we can run a temperature higher, we can use warm water. So if we can use warm water, we can start doing some interesting things.
Oh.
So, for instance, this is a rough cartoonish sketch, but it hits home with every customer that I ever show it to. This is an example data center, and this is traditionally how it's done. I have elements removed, and I'll explain that.
Okay.
So, within your data center, you have a computer room, and you have your compute systems. Well, in there you have your common AC unit, right? This is typical.
Yeah.
It goes through a pump, goes through a chiller, goes through a heat exchanger, and goes to a water cooler, right? This is typical. Well, what we do, because we do this as a closed loop system and support warm water, we can easily pull out the AC unit, we can pull out the chiller, we can pull out the heat exchanger, we can pull out the tower even, if the customer will take this warm water. See, when you pull air into a computer system, it's no-brainer, right, that you heat things up. So what we want customers to do, and this is forward-looking, we haven't deployed a customer doing this exact process yet, but it's capable of it. So it's forward-looking. If we have a customer who will take the hotter water that comes out of the system, take it over to a secondary process. Say you have a data center in Alaska, you have your computers in one area, you can heat your rooms in the other, and then it loops back, right? So you're paying for the power to energize the system, and you're creating heat. Use it. This is the efficiencies. These are nibbles that we can take, right? So this is hardware. That's not going to be enough. There has to be lots of nibbles to get us to exascale. So with Altair, for instance, we're doing a project with them. Our engineers are very closely tied, wherein we take it down to the job scheduling level and create efficiencies there.
So Paul, can you tell me more about this power management project in terms of Exascale and what you guys are up to?
Sure. Well, firstly, I want to say good workload management tools and schedulers are I don't want to say hard to come by, but not all job schedulers are created the same. Just like with hardware, there's companies who had a longer go in the industry. Their solution is more robust. It can scale. The cost, performance metrics are in place, and certainly that's the case with Altair. So again, we do a lot of work with them and have for quite some time. But specifically in terms of workload management, so when a job is submitted to a system, by a user, it gets dispersed across the cluster. Within the industry, in terms of power management, it's just kind of now coming into play where you can control the power, right, at the node level, somewhat, I guess, analogous to like a dimmer switch. If we think of a large computer system with a dimmer switch, you can turn it on, turn it off at the system level. You can dial the power usage up or down based on user, based on time of day, based on whatever policy you want to set up in a fine-grained way. But And you can do that on a node level basis. This is, power management at the node level. Enter the job scheduler, who in the rest of the industry is just blindly distributing the jobs across the system without any recognition of the implications of power in doing so. What the work that our engineers is doing with the Altair team, it's equally being done, is to do that intelligently. So when a job is going to be submitted, they can look across the cluster and say, where is it exactly I should place this job? Not just scatter it, right? But intelligently place it so that the amount of work, the amount of power that load consumes is optimized and is minimized, right? And then it doesn't take much to start, churning the wheels of, hey, what else could I do? Well, you know what? You could do predictive type of analysis. You've got this job and you say, what happens if I submit that now? What happens if I submit part of it now or all of it later, right? When power in the evening is at its lowest cost, for instance. That's easy to do, but to do that as a job scheduler, to look across the cluster and understand how do I optimally place this in a predictive way, is leaps and bounds past what anybody else in the industry is doing. Now maybe they're thinking it, but we're doing it. So again, this is like another nibble. So besides, we're SGI on the hardware side and the software side have taken power management and power efficiency a long ways. Our original customers, our genesis in the company is putting gear into places that don't have much power, don't have much cooling, so they have to be very efficient. So for us, it's like we're coming into our own, where the industry now desperately needs these cool solutions that our engineers have done for 20, 30 years. Let's look back. Some of our engineers, so liquid immersion is kind of coming into play again, and we're hearing, I say again, right? Because our engineers have done that already. They've done all the exotic cooling. And it's not quite time for that yet, although we're paying close attention to it. But like we're paying close attention on the hardware side and the software side, we partner very closely with rock stars like Altair, so we can do that all the way down to the job level.
Yeah.
This is a natural evolution as we move to greater scale that is really pushing the power envelope.
Yeah, when you have these extreme requirements for power, it sounds like power can't be an afterthought, especially at the system level. This has got to be a primary consideration of how the thing operates.
This has to be designed up front, exactly. And lots of vendors, if you walk around the floors, will tout, I have platinum power supplies, I'm running 480 for efficiency. Yeah. But you got to go beyond that. And this is what I say that SGI does, right? We're taking care of the problems that the customer has so they don't have to. The customers are asking, what are you doing about power? What are you doing about this? What are you doing about that? We're finding the answers to that. We're exploring the options for that so the customers don't have to. They can solve their problems at scale.